In this video, we're going to explain nominal, ordinal, interval, and ratio levels of data. Together, these terms are known as the 4 levels of measurement in statistics. Here, we'll unpack each of them in simple terms, along with loads of examples, so that you can approach your analysis with confidence. Now, if you're new to the oftentimes intimidating world of academic research, be sure to hit that subscribe button for loads of plain language, actionable advice covering all things research related. Also, if you're working on a dissertation, thesis, or research project, check out our free collection of easy-to-use chapter templates to fast-track your research. You can find the link to those in the description. Right, with that out of the way, let's jump into it. Okay, so let's start with the basics. When you're collecting survey data, or really any kind of quantitative data, you're going to land up with one or both of 2 types of data, categorical and numerical. These 2 types reflect different levels of measurement, to be specific. Let's unpack them. Categorical data, as the name suggests, means data that reflect characteristics or categories. No big surprise there. For example, categorical data could include variables such as gender, hair color, ethnicity, or even coffee preference. Simply put, utilizing categorical data is essentially a way of assigning number values to inherently qualitative data. For example, you could assign number 1 for female, number 2 for male, and so on. Numerical data, on the other hand, reflect data that are inherently numbers-based and quantitative in nature. For example, age, height, or weight are all things that are naturally measured as numbers. This contrasts against categorical data, which, as I mentioned, involves assigning numbers to qualitative characteristics. All right, so we've got categorical and numerical data as a foundation now, so let's drill down further. Within each of these main data types, there are 2 levels of measurement. Within categorical, there's nominal and ordinal level data. And within numerical, there's interval and ratio level data. But why do we need all these levels, you ask? Well, the reason it's important to define types of data is because the level of measurement for any set of data will directly impact which statistical tests you can and can't use on it. For example, you can only calculate the mean, the average, for certain levels of data. If you try to run a statistical test on an unsuitable data set, data that's at the wrong level of measurement, you'll end up with meaningless results. So you need to understand what you're dealing with before you can really work with the numbers. All right, so let's unpack each of the 4 levels of measurement, along with some practical examples. Nominal data, a categorical data type, describe qualitative characteristics or groups with no inherent numerical value, order, or rank between categories. For example, gender, ethnicity, or blood type, the brand of appliance someone owns. For example, a refrigerator, microwave, etc. Or someone's personal preferences. For example, their favorite meal or favorite color, etc. In all of these examples, the data options are categorical, and there's no ranking or natural order. In other words, they all have the same intrinsic value. One color, for example, is not ranked above another. Simply put, you can view nominal data as the most basic level of measurement, reflecting categories with no rank or order involved. Nominal data generating questions are often used in surveys to collect sample demographic information, such as gender and ethnicity. They're particularly useful for comparing how responses vary among these basic dimensions. For example, if you wanted to assess statistically significant differences in responses between men and women. So nominal level data, the most basic of the 4, can still be very useful, depending on your research aims. All right, so now let's take a look at nominal's big brother, ordinal. Ordinal level data kick things up a notch. This type of data is the same as nominal data insofar as it describes categories. But unlike nominal data, there's also a meaningful order or rank difference between the options. Some examples of ordinal level data include income levels. For example, low income, medium income, or high income. Levels of agreement. For example, disagree, neutral, or agree. Levels of satisfaction, for example, poor, average, good, or excellent. As you can see in these examples, all the options are still categories, but there is a natural ordering or ranking difference between the options. You can't numerically measure the differences between the options because they are categories after all, but you can order or logically rank them. Simply put, ordinal level data reflect categories with a natural rank order. Right, now that we've covered the two categorical levels of measurement, let's take a look at the two numerical levels of measurement. Interval level data are numerical data. In other words, this level of measurement involves naturally quantitative data that are, by default, measured in numbers. Specifically, interval data have an order, like ordinal data. But in addition to this, the spaces between measurement points are equal, unlike ordinal data. Sounds a bit fluffy and conceptual? Well, let's make it a little more tangible. Some examples of interval level data include credit scores, which range from 300 to 850. GMAT scores, which range from 200 to 800. The temperature in Fahrenheit. The Fahrenheit bit is important though, and I'll explain why a little later. Notably, in all of these examples, the data points are naturally numerical. They're always expressed in numbers, and the spaces between measurements are equal. For example, the difference between a credit score of 610 and 620 is the same as the difference between 650 and 660, 10 points. However, if you look closely at all those examples, you'll notice that they all have something else in common too. That something is that the 0 point is arbitrary. For example, a temperature of 0 degrees Fahrenheit doesn't mean that there is no temperature or no heat at all. It just means that the temperature is 10 degrees less than 10. Similarly, you cannot achieve a 0 credit score or GMAT score. Well, let's hope not. Simply put, interval is a level of measurement that's numerical. You can measure the distance between points, but that doesn't have a meaningful 0 point. The 0 is arbitrary. So interval data offer a more sophisticated level of measurement than nominal and ordinal, but it's still not perfect. So enter ratio data. As you've probably guessed, ratio is the most sophisticated level of measurement. Just like interval level data, ratio data are ordered or ranked, and the numerical distance between points is consistent and can be measured. But what makes ratio the king of measurement levels is that the 0 point reflects an absolute meaningful 0, unlike interval level data. For example, weight, height, or length. You can see how a 0 value is meaningful here. The temperature in Kelvin, since 0 Kelvin means 0 heat. A length of time, for example, seconds or minutes or hours. In all of these examples, the 0 point is absolute. 0 seconds quite literally means 0 duration. Similarly, 0 weight means weightless. In other words, it's not some arbitrary number. This is what makes ratio the most sophisticated level of measurement. With ratio data, not only can you meaningfully measure distances between data points, i.e. add and subtract, you can also meaningfully multiply and divide. For example, 20 minutes is indeed twice as much time as 10 minutes. You couldn't do that with credit scores, interval level data, as there's no such thing as a 0 credit score. So as you can imagine, you can do a lot more in terms of statistical testing with ratio level data than you can with lower levels of measurement. Okay, so let's do a quick recap. At the highest level, we've got categorical data, which are more qualitative in nature, and numerical data, which are quantitative by default. Within categorical, the two levels of measurement are nominal, categories with no inherent rank, and ordinal, categories with a natural order or rank. Kicking things up a notch, numerical includes the two measurement levels of interval and ratio. Interval level data are measurable in that the spaces between measurements are equal, but it doesn't have a meaningful 0 point, whereas ratio level data, the king of measurement levels, does. It's also worth mentioning that numerical level data, interval and ratio, are continuous data types as opposed to discrete. Also, if you're planning to use SPSS, it's worth noting that numerical data are referred to as scale data, and this covers both interval and ratio level data. If that all sounds like gibberish, don't stress. We cover all of it in more detail on the Grad Coach blog. Link below. If you enjoyed the video, please hit the like button and leave a comment. For more videos like this, check out the Grad Coach channel and subscribe for plain language, actionable research tips and advice every week. Remember, if you're looking for one-on-one support, you can check out our private coaching service where we hold your hand throughout the research process step by step. You can learn more about that and book a free initial consultation at gradcoach.com.